Good evening and welcome everybody to the BCS Learning Development Specialist Group and to our talk tonight on code grades. Just before we get started, just a couple of slides just about the group itself. So Michelle, if you can go to the next group, next slide. So BCS Learning Development Specialist Group is primarily for those involved in the development, delivery or management of learning to IT and communications professionals and users. So hopefully all of you joining the call tonight fit yourself into that category somewhere, but we're very much interested in everything to do with skills and IT in all aspects. And on next slide. Just to give you a profile of the membership we have of this specialist group, it's everything from end user skills training people, professional skills trainers, which is particularly things like ITIL and prints, IT technical skills, so product orientated technical training. 16% of our group are people who are from the education sector or university, academia, and a third of the group just have a general interest in IT skills. And finally, just an advert, our next event is going to be on how to conduct online proctoring and stay compliant with the GDPR. So if you're involved in any form of online assessment at the moment, then it's a talk that I saw recently at an IT industry trade association event, and definitely recommend it. It's very enlightening as to things that we should know about when we're working in an online environment, as so many of us are at the moment, and some other events that we're working on putting together over the summer. And anytime, if anyone has any ideas or you'd like to get involved in the Learning Development Specialist Group, then please contact myself and I'll be happy to talk to you. Okay, next slide. So over to tonight's talk. So I'm delighted to welcome Nicholas Tollervey to talk about code grades. And Nicholas, I'd like to hand the floor over to you, and I think you're introducing yourself a bit at the beginning of the talk. So
thank you very
much. Welcome, and looking forward to your talk.
Thank you very much, Kevin. Thank you. I just need to wait while I'm given the right permissions to do things. So let me just figure this out.
You're good to go.
Good to go. Right. I want to show that, and I probably also want to put my webcam on as well. Okay, and so I just need to check with folks. Can you see my slides?
Yep. You're all set up, all good to go.
Okay, well, thank you very much for inviting me to talk. It's a real privilege. So my name is Nicholas, and I am actually a freelance Python developer working in the UK. But as you'll see, there's a little bit more to this story than meets the eye. So actually, this second slide is me in my natural habitat. Before I was a software developer, I was a classically trained musician. I trained at the Royal College of Music. This is going to be relevant to the talk, by the way, which is why I'm telling it to you. And I also played professionally, and obviously my instrument is the tuba. I'm an orchestral musician, although I also play piano and organ. And I went through the UK's music education system, which is as well another pertinent aspect of this evening's talk as well. But since there are probably more pandas in the UK than there are tuba players, or tuba jobs, I did the wise thing when I was trying to work out what am I going to do to earn some money so I could get married and things like that. And what in fact I did next is what pretty much most musicians do when they need a regular secure job, and that is I became a school teacher. And the slide that you see there is me on my first day at school quite a number of years ago with my form. I had just qualified as a newly qualified teacher in that photo, and I'd been appointed at 23 head of department as head of music. During my teaching career, which spanned most of my 20s, I've worked with pretty much every age group from early years, Key Stage 1, through primary, Key Stage 2, obviously working with teenagers, Key Stage 3 and 4. I also did adult education as well, working with adults in music education. And also, at the same time, I read for an MA in philosophy of education as well, because I wanted to pursue the academic aspects of and philosophical aspects of learning and pedagogy and teaching and training and curriculum development and all those sorts of things. But when my own children started arriving in my late 20s, I decided that I wanted a career change to do something else, and that's when I went back to coding. So I use Python mostly, although I'm a polyglot programmer. I know quite a number of languages, but the thing that I'm usually paid for is to write Python code for people. So, for example, at the moment, I'm working for the UK government, doing some stats things for them. In the past, I've worked for people like The Guardian, done some work with the BBC. I've won awards from Google for my open source work, and I've been quite active in the Python community as well. This picture of me is from last year, and I've just realized I'm wearing the same shirt as I am in that photograph. I have more than one blue shirt, but that's me leading the Beginners Day. So I still take an active role in teaching and training coding, in particular in the Python community. And so that was last year's EuroPython, the Beginners Day. So what am I here to tell you about? Well, I'm here to tell you the story of Code Grades, which is a project to help folks acquire the coding skills they need to create the stuff that they want, essentially. Now, I realize that in terms of the group, you're quite a broad church, but this particular talk is going to be quite focused on how do you teach coding in particular. Now, the attitude that I'm going to take is that of a lazy developer. Now, often it's said that for software developers, being lazy is a good thing because you don't want to keep reinventing the wheel. It's a lot better to reuse other people's code and effort and build on the shoulders of giants and that sort of thing. So I'm going to try and do as little original work as possible in this process, and we'll see how we get to Code Grades. So first of all, where are we now? What's the narrative around learning to code? Let's examine the usual reasons folks give for promoting coding education. Famously, Mark Andreessen said, software is eating the world in a Wall Street Journal article. Mark is obviously quite a famous developer. He created one of the first popular graphical web browsers called Mosaic, went on to found Netscape, which eventually became Mozilla, and he's now one of the most successful Silicon Valley venture capitalists. So software's everywhere, is his point. Then, of course, you get journalists like Doug Rushkoff. Doug's point here, program or be programmed. The real question is, do we direct technology or do we let ourselves be directed by it and those who have mastered it? Well, Doug's point is that ignorance of coding disempowers you in today's world. If you can code, you have the autonomy to make the digital world as you see fit. And I'm sure you'll agree, autonomy is an important aim for all educators and all sorts of training, because as trainers and teachers, in effect, we're in a way trying to do ourselves out of a job, because we want our students and the learners and the people who rely on our resources to be able to do the things that they need to do without having recourse to have to ask people they're acquiring skills or knowledge. Okay. Also, you'll see in the press as well, there's a lot been going on in the last, 5 or 6 years, and this is a classic example from Forbes. Businesses across the wide range of industries are seeking professionals with programming and coding experience, even if their company's work is not directly related to technology. So lawyers and doctors and teachers and weather folks and financial people are all going to need to at least have some coding skills or knowledge of coding skills, because there's a good chance that a significant minority of their colleagues are going to be software developers like me, who are making computers do interesting things in their particular field of endeavor. And if you don't have that that window on the potential of the coding world, then you're sort of driving blind, really. So hence, coding is disrupting everything, all the different sorts of industries across our economy. So no matter the industry, it'll be using computers in some form or another. And for the sake of the economy, we don't want to be the equivalent of the illiterate ones trying to work in a library. It's far better to actually understand what computers are doing from a coding point of view, to be able to, as Doug Rushkoff said in the previous slide, actually program rather than be programmed. And finally, actually, coding also has a bit of an image problem. Hollywood doesn't really help. Most coders, when you see them in the media, are white, straight dudes who write code very, very quickly at a keyboard, and there's windows flying all over the place, and they put their hoodies up and they're hacking the mainframe and bypassing the firewall and all this sort of stuff. And it's not like that at all in industry. As a professional software developer, I can tell you that. And diversity is a strength. The problem that we have in the software development industry is that underrepresentation is a big problem. Most people look and sound like me, and that's not good, because when we write our code, we are writing from a particular point of view, and the code that's delivered to clients that the users get to use reflects our particular worldview. And it's not just people who look like me who should be able to express themselves. So it's important that a wide diversity, a wide variety of people come to coding, so that the software that is produced represents a good cross-section of the community of people who are using it as well. The other aspect of the stereotypes and the image problem that I just want to touch on is that people seem to think that coding requires you to be some sort of mathematical genius, and it's all very highly technical and confusing code, like the things that you see in the slide there. Actually, if I'm honest, in my day job, I spend not a lot of time actually writing code. I spend a lot of time reading documentation. And as you know, I'm a classically trained musician, and my maths is at high school level. Is the last qualification I took for mathematics. So we have a bit of a intimidating image, really, in terms of brainiac type nerds, and this is something that I also wish to shed. David Heinemeier Hansson, who created a web framework called Ruby on Rails, famous among software developers, said actually we're software authors, not software engineers, and he wanted to bring out the sort of more literate aspect of being a software developer. The fact that writing code is all about expressing an idea in a way that the computer will understand, but writing it in a way that your future self or your colleagues will be able to understand the code that you've written as well. And also the clarity of thought and being able to express yourself in as simple a way as possible that involves is also a good way of making sure that you are actually solving the problem in hand, and not just writing what I would call spaghetti code, and you get a big mess of software full of bugs. So coders don't need to be hoodie-wearing misfits, nor do they need to know kung fu like Neo in the Matrix. So enough of that silliness. Given that there is this skills-based narrative about people need to upskill into coding, and it's not just coders who might need that, it's a wider segment of the folks working in industry. What are folks doing at the moment to address this? So if we start at the very beginning with perhaps children, this is a Raspberry Pi, a board for kids. It's a worldwide success, a fantastic job, millions of units sold. But what does it do? What can you do with it? This is a question that puzzled me for a while. I mean, obviously I'm a programmer and I can plug it in and I can make it do things, but at PyCon UK we had a troop of Girl Guides come along, and we gave them all a Raspberry Pi. And when I followed up with them several weeks after the conference where they were being shown how to make things happen with the Raspberry Pi, I asked them how many of them had actually taken the device out of the box, and one of them had, and this is out of a troop of around 40 of them. So you might be given some hardware, but you still need to try and figure out, well, what do I do? And then, of course, there's another approach to this, which is the BBC microbits. 1 million of these were given out to every 11-year-old. Sorry, 1 million 11-year-olds got one of these a few years ago. And in a sense, it's the BBC recapturing the glory days from the 1980s with the BBC microcomputer. Obviously, this is a microcontroller. It's not a full computer. It has buttons and a screen, and it's a kind of a fun little device. In fact, I've got one right next to me here because I was involved in making the microbit. I was involved in all the Python aspect of that. But one thing I can tell you is that nobody actually asked the teachers what they wanted. And many of these devices, when they were delivered to schools, remained unused. And of course, others, so this is an American board from Adafruit, have created other other beginner-friendly devices that attempt to get people hooked into programming. You can make a little doohickey do things, and it makes a noise, and it bleeps and blurps and things like that. But still, you know, given a piece of hardware, you're still posed with the question, well, how do I make stuff work? And the answer is, of course, you write software. Okay. Now this is interesting because folks have started to produce resources, obviously, for the Raspberry Pi. The Raspberry Pi Foundation have an excellent education team who are always producing some really good resources. The same with BBC Microbit. Adafruit do an amazing job, best in class at this sort of stuff. But to introduce Dawn, as she once said to me in a conversation, what we're doing is we're making lots of content rather than progress. And Dawn's point was there's too many blinking LED examples for learners and Magic 8-ball Python libraries, but there's not a lot of progression. So there's lots of print hello world, but there's not a lot of stuff that gets you from making those initial footsteps, from taking those initial footsteps through to actually reading the sorts of documentation that I might need to read during my working day, when I need to onboard and get my head around a whole bunch of stuff as a professional developer when I do my learning. Okay, so the other aspect of this, here's a Magic 8-ball, is that such problems are solved problems, and often they don't speak to beginner programmers. When I've spoken with beginners, they are full of ideas. And then I say, but we're going to make a Magic 8-ball. What's a Magic 8-ball? Well, you shake it, you ask it a yes/no question, and then it will go yes or no. It's a very simple program, and it's not particularly exciting, okay? And such projects really don't give beginner programmers much opportunity for play and experimentation either. Okay, you've done your project, you've cut and paste your code off the internet, and you've made it work. Well done. And that's not really a great way, or it's not really a way of explaining what I do as a software developer. It's not a true reflection of what a software developer actually does. I actually sit down, I research, I think, I write code, and I debug code and things. Okay, so so we have these sorts of solutions to our skilling up in coding in the employable in our future generation. But what happens at GCSE and A level? That's important because these are teenagers, okay, in late stage teenagers, and they are at a cusp where they are choosing, what am I going to do with my life? And we are presenting them with a curriculum about computing and a GCSE and an A level that helps them make that choice. Now, whilst GCSE computing is a broader subject than just coding, I want to focus on coding. And sadly, all of the marks in the AQA GCSE, and I'm showing you an extract from their syllabus, all of those marks are obtained via written exams in a sort of a closed book situation. Here's the next one, theoretical knowledge from subject content 3 to 7 above. It's a written exam of 1.5 hours, 80 marks, 50% of the GCSE. What are the questions? They are a mix of multiple choice, short answers, longer answers, and extended response questions, assessing a student's theoretical knowledge. Wouldn't it be great if there was some practical coding going on? Well, it turns out there is. There's a programming project, but this looks really more interesting, and it allows the students to actually practice creating a project. But, and here's the big but, they get 0 marks for it. So if I were a teacher or a student, I think a legitimate question to ask would be, well, what's the point of doing this if it doesn't contribute to my final grade, which is the thing that's important? And I would add that I feel very sad and disappointed that a qualification in computing that's supposed to be something that includes coding doesn't actually have any practical coding that's used as a form of an assessment. Now, I realize exam boards have their hands tied to some extent by the government, but as a person from industry, I'm sorry, this looks sort of a little bit like a joke, really. What do you mean you have a closed book coding exam where you have to write down on a piece of paper code? I don't write code down on a piece of paper, and I certainly look up things on the internet all the time. My feeling is, and I understand that our colleagues in school face lots and lots of challenges, but my feeling is that we have a long way to go with GCSEs and A-levels and computing when it comes to making them interesting and, perhaps more importantly, relevant when it comes to coding. What happens if you're out of education and you want to train as a coder? Well, if you're an older learner or you want to change careers, then boot camps are one option if you can afford them. However, it costs between £8,000 to £10,000 to attend a boot camp, and typically they're only around 3 months of intensive learning. And actually, I've trained many graduates of such schemes as well, and we'll come on to that later on. I mean, they're one solution, but hopefully I'll be able to show you that there are perhaps other ways that we could go about doing this. Finally, of course, if you want to upskill in coding, you could do it on your own. You need to be a very brave person to do that sort of thing, because while the internet is a wonderful resource and you'll be able to see lots of videos and take free online courses of varying degrees of quality, there's nobody there who's acting as a mentor, who's there to show support, to give you help, or to give you the encouragement that you need when inevitably you hit roadblocks. Okay, so with that in mind, here's the problem. We need to help people learn to code. Here's kind of where we're at when it comes to training coding. I want to introduce you to a thought experiment. Now, let me set the scene. I was in Boston. I was in New York, traveling to Boston on a train. And I'd wanted to do this journey since I was a teenager, because as a teenager, I had loved the music of George Gershwin. And George Gershwin created a piece of music called Rhapsody in Blue. And as he was boarding a train from New York to Boston, he read in a newspaper in the 1920s that he was going to have a world premiere in the Carnegie Hall in 2 weeks' time. And Gershwin had forgotten this. But what he did was he'd sketched out by the end of the 3.5-hour train journey from New York to Boston the bare bones of Rhapsody in Blue. And by the time he pulled into the Boston station, he knew he could do this. Okay, so I wanted to, for musical sentimental reasons, relive this train journey. Okay, and I wondered, well, what sort of inspiration would strike me on this train journey? And well, this is the inspiration that I had. I asked myself, what if we taught music like we teach programming? Okay. And I was thinking about my own musical education. I was thinking about my experience as somebody teaching coding. And I was thinking about my experience in meetings in New York, talking to folks about how they approach teaching the Python programming language. And it all sort of merged together, and this question came up. So what's going to happen is I'm going to show you a few slides now. They're a little bit humorous, but this is what I imagine music education would look like if we taught it like we teach computer programming. So for a start, you could go to a boot camp and you could learn to music in 12 weeks. And like most boot camps, you could train with them and they would guarantee your first job as a musician. You just need to fill in your email address and they'll give you lots of emails about how you can sign up, so long as you can afford it, okay? Guaranteed a job waiting for you at the end. Alternatively, we could just give everyone arbitrary instruments. They'll pick it up eventually. I imagine that giving all students, all learners who want to learn music a tuba sounds like a great idea. They'll pick it up eventually. For me as a tuba player, this sounds wonderful. Alternatively, damn it, standards require that we have written exams for music, okay? So musical thinking and problem solving, we're going to give you a written assessment that's a mixture of multiple choice, short answer and long answer questions assessing a student's practical and theoretical musical and performance skills. Or you could just read the book about music and wing it. Nothing beats reading a book, right? Or, well, actually, do you need 12 weeks in the boot camp? I mean, you could do Sam's Teach Yourself guides in 24 hours and learn the piano, for instance. Actually, back in the land of coding, just have a look at this tweet. Somebody has said that they have created a course that teaches you Python in 30 minutes. My gosh, this is amazing. And then a chap called Guido van Rossum has pointed out that you can't actually learn a programming language in 30 minutes. Now, who is this Guido person anyway? What does he know? Well, he invented Python. He's the creator of the Python programming language. And I can tell you, because I know Guido, he is very interested in education. And one of the reasons why Python is perhaps such a strong learning language is because of that interest in education that Guido has. Now, I want to point out about boot camps. If you have £10,000, there's nothing wrong with a 3-month boot camp. But you will program like someone who has only been coding for 3 months. In the same way, would you hire a musician who'd been to a boot camp for 3 months to play at your wedding? Ask yourself that. Like learning to play music, learning to code takes time, effort, discipline, and perhaps most importantly, practice. Furthermore, please believe me when I say that learning to code means picking up a certain sort of a culture, heuristics, practices, and a history so that we don't keep reinventing the wheel. So it's not just about knowledge acquisition, filling people's heads in 3 months or getting them to be able to tick the right sorts of boxes, okay? Now, I mentioned that I've trained rather a lot of bootcamp graduates, and what I want to do is take you through the sort of level at which they get to by the end of the boot camp, just so that you get a sense of the sort of progression, because progression is an important aspect of this conversation. Where do they get to by the end of a boot camp? Okay, and can you code like a pirate? This is a simple, fun question that's often used to break the ice in coding interviews or code dojos. What I'm asking people to do in this very simple exercise is, given a sentence of English, a string of characters that represent an English sentence, can you turn it into something that sounds like a pirate saying the same sentence? So you emit a string of characters that instead of says, hello there, it goes, ahoy matey, or something like that, okay? Just to give you a flavor of what that might look like, I'm just going to play you a video of a live coding session of a solution that's been created. So I'm going to import the pirate library, and I'm going to call the pirate translate function with a sentence that says, hello there, are you having a good day? Question mark. And if I run it, I get back, ahoy there, are you having a good day? And if I do it a few times, you can see at the very end, it randomly, on occasion, adds a random pirate phrase. Okay, this is a very simple coding task. Now, here's the solution, written in Python. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 Python statements there that allow you to do that. Okay, now I've never met a boot camp graduate that could do this. Okay, and this is no disrespect to boot camps or their graduates, but while they have the knowledge, they don't have the culture, practices, or perspectives to quickly solve this sort of problem. Okay, how do you engage with a software problem? How do you break a software problem down? How do you take the knowledge that you know and apply it to the problem that is in hand? How do you go about searching on the internet somebody who might have already written a Python library that does the translation into pirate? Well, it happens that somebody already has. I put the link at the bottom there. Okay. So what I'm saying is that a lot of my training with these graduates is, so you've done your 3 months, that's great. I can ask you what a RESTful API is, or I can ask you what tail call recursion is, or I can ask you how Python does this, that, or the other in a Django web application, and you will tell me the right answer. But if I ask you, or if I give you a problem to solve, the application isn't there. So we need to do something about this. And this is where the second thought experiment on this train journey to Boston comes about. Learning to play music is like coding. It's a difficult skill that takes a lifetime to master. There's lots of theory involved. You have to practice to improve, and there are many ways to do it. So diversity here is a strength. So what would happen if we taught programming like we teach music? So how do we get from this young learner playing on their violin? So when I show you the following pictures, I'd like you to think about how this maps onto coding education, especially programming and Python and things like that. So how do we get from this to a concert violinist, Nicola Benedetti in this case, or Ali Beale, a famous Ali Bale, a famous folk fiddler from Orkney, or I don't know, the BBC Concert Orchestra, or some folks having a lovely time just improvising in a folk session in their local pub, or even this, a kind of a thrash metal cellist or something. Okay, how do we do that in the music world, and what can we copy from that in the coding world? Okay, so this is my point here. What I've done is done the software developer's trick of, surely somebody's encountered this problem before. Somebody's encountered this problem of how do you upskill somebody in a hard to acquire skill, and what can I learn from those people who've done it before, and how can I reapply it to the problem that I have now? Okay, so my background is in music. I've been trained as a musician, so I've been through the conservatoire training. I've also taught music, so I know the music education from the other side. What could I steal from music education? Okay, so lazy engineers don't reinvent the wheel. Good artists copy, great artists steal. I could plunder 900 years of music education theory here and practice. So this is where we get finally to code grades. In the UK and in other Commonwealth countries, what we have is something called a grading system. Okay, and they are 8 steps for each individual instrument. And each of those steps takes you from beginner to not so dangerous beginner. So grade 1, you're very, very much a beginner, like this young lady here. Grade 8, you know enough about your instrument to know that you've got a lot more to learn. But you are a very capable musician, nevertheless, when you get grade 8. Okay. The important aspect about music grades that I want to bring your attention to is that the syllabus is created by professional musicians. These are people working in the industry. Okay, and they are using whatever context is happening in the music industry to inform what should be happening in the music grade system. Another aspect of the music grade system is that examiners are professional musicians as well. So when somebody is listening to you honking away in your trumpet in grade 3 or mangling the keys in your grade 5 piano exam, they are a pianist and a trumpet player. So they understand what it feels like to do the thing that you are doing. And perhaps even more importantly, a grading contains practical assessments that reflect what a musician actually does and requires knowledge of what a musician needs to understand. So it's not like, sadly, the GCSE exams where you have to tick some boxes or answer questions in a very constrained examination environment. Essentially, what you do is you give a little recital, you're given oral tests, you sing a little bit, you play some scales and arpeggios, you're asked some questions about the Italian terms and the German terms we use, and generally have a conversation with the examiner who's in the room with you. And what happens then? Well, what happens is that you're given very supportive feedback, written commentary, and you're provided with marks and suggestions and improvements for further development. Okay, it's important to note that the grading system is for learners of all ages across all the different instruments, and as I've just explained, there is a focus on cultural practices in music. Okay, so what is it like to stand up and play a clarinet in a small recital where you walk in, you do these sorts of things, you play your piece of music, you breathe in these sorts of ways, you look at your accompanist in that sort of a way, and all the time the examiner is watching you and trying to work out how they can best give you some supportive and constructive feedback at the end of it, along with some marks to tell you where maybe you get a sense of where you are in your path as a musician as well. So it's a friendly and supportive, if nerve-wracking, experience. And finally, getting a grade is validation of attainment by an expert in the field. So if I get grade 5 piano, nobody can take that away from me. In fact, in music education, if people want to audition for an orchestra, they'll often say you need to be grade 5 or above to do this. So you get a sense of where you are in your learning journey and what sort of things you could join or go to that would best suit you on your learning journey. Okay, so finally, code grades. So my idea is, could we take the modus operandi of the music grading system and apply that to software? So this is an experiment that I've been running for the last 2 years. I've used it with several cohorts and it's gone quite well so far. So I have written a syllabus with some other professional coders for Python. There are 8 grades, just like in the music syllabus. Grade 1 is all about taking your first steps in coding with Python, whereas grade 8 gets you to a level that's the equivalent of what I would consider as a professional software developer, a level that I would consider as a good junior programmer. Okay, so you've got over the little bit of knowledge is a dangerous thing type bump that often people have with coding. Okay, so what happens in a code grade? Well, what you do is the syllabus tells you the sorts of skills and knowledge we expect from you at that particular grade. Grading is cumulative, so if you're taking your grade 5, we expect you to know all of grades 4, 3, 2, and 1, and so on. Okay, and what you are asked to do is present to a professional software developer a project of your own devising. So we're not going to ask you to build yet another hotel booking system or a magic 8-ball or something like that. Beginner coders have lots of imagination and they can create their own projects. They have a lot of impetus to create their own projects. And so this is what we ask them to present, is something that they have ownership over. And that project should show all the skills and the knowledge required for that particular grade and those that have gone before, because like I said, it's cumulative. This is done as a formal code review, which is something that I do all the time with my colleagues. And it's a practice that happens in industry. Okay, so we are practicing what software developers do. We write code, we show it to other people, they review it, we might make changes, we talk about the approaches that we've taken in our code, and we learn from each other. Okay, the second aspect of the grading is that we do something called a paired programming task, where the candidate is given an unseen fragment of code and they are asked to fix a bug in it. Now, it's made clear to them that actually we don't really care if they fix the bug or not. What we're more interested in is the approach that they take to fixing the bug. And in the assessment criteria, and we make it very clear what we're looking for, we make sure that we're looking for things like they are collaborative with the examiner, who's going to be their wingman or partner in this collaborative coding exercise, and they're going to be able to sort of ask questions. They're going to look things up in the right way, in the right place on the internet, so they get the right sort of answers. And so that what we're looking for is that they have some sense of autonomy, that they have the smarts to be able to write the code that they need to do for that particular grade on their own, and they're not afraid to ask for help as well. Okay, so I've done this 2 or 3 iterations and it's gone very well, and each time what I'm doing is refining and refining and refining. Okay, currently I'm working with some other people that I know, and we are creating resources so that people are able to learn what they need to do to take a particular grade. Okay, and what's going to happen next? Well, we're hopefully putting the icing on the cake of our website, so that people will be able to apply for a grading exam in Python initially, although this could be other IT related skill sets, for example, different programming languages, or web development in general, or relational databases, or cloud computing, or something like that. And what do they get at the end of a grade? Well, they get, just like with the music grade, written feedback, some marks, so they get a sense of how they're doing for particular dimensions of the things that we're measuring for what makes a good coder. And the results have been really good, because the ultimate question that I ask the candidates that have been through is, do you want to do another one? And I'm pleased to say they've all said yes so far. It's been a positive experience. So I'm going to end on a quote from me, as it turns out, in a discussion about coding education, asking what sort of education and learning our community supports is how we decide what sort of community we become. For it is through education and learning that we engage with our future colleagues, friends, and supporters. And rather than and what I hope that we can do through code grades is put them in touch with people practicing as software developers in the industry right now, so they can act as mentors, and they are actually learning a syllabus that is created by professional software developers, that gives them the skills and the confidence that they need to build the stuff that they want to do. And that's it from me, and I finished 1 minute over. So are there any questions? And now that I've just moved my presentation notes, I noticed that the unread chatter. Okay, so do we have any questions?
So I'm just trying to see if I can turn my camera back on. Let's see if that works. Very interesting, Nicholas, and it makes obvious sense once you talk about it, but yeah, it's not an obvious place to start from. First question is, obviously in the music world, the syllabus are all published for each grade and for each instrument. Is that where you're heading with this, is to have a published syllabus of sort of here's what's expected of, say, a Python programmer at grade 3? Yes, absolutely. And again, using the lazy developer analogy, I've used the same sort of format for figuring out what the structure of the syllabus should be, because in the music syllabus, the early grades are all about coming to terms with your instrument, having fun, so you get the wind in your sails. The middle grades are all about picking up all the essential skills that you need at a basic level, and the higher grades, 6, 7, and 8, are all about refining those skills, so by the time you're a grade 8 cellist, you can play that sonata, that solo cello suite by Bach that you've always wanted to be able to play. So it's the same sort of idea with the code grades. Another aspect of this is actually quite interesting, and I speak from experience. I remember starting playing the piano and going to a concert that was run by my teacher and seeing somebody who was grade 3, and I hadn't even taken a grade, and I thought they were amazing. My gosh, you know, they sound incredible. Okay, but it didn't take me long to get to grade 3, because when I'd done my grade 1, I could see grade 2 on the horizon. It didn't seem so impossible. I'd done my grade 2, grade 3
then I know what I need to do for grade 3, and you start to get a wind in your sails. There's kind of an impetus here. There's sort of these act as stepping stones to help you cross the river, ford the river that you need to get to the other side of the bank where you've got the skills that you need.
Yeah. I guess two things come to mind, and then we'll open up the microphones for questions, or if people want to put questions into the chat. But the first one is from this group, we've done a number of sessions about digital badging and digital credentialing, which is exactly the same idea about feedback, often relevant, continuous feedback, so that you know you're making progressions. So yeah, that's obviously a very, very hot topic at the moment, and certainly across the IT skills industry, badging is the thing that everybody's getting into at the moment.
Yes.
The other thing is, obviously, a lot of what you're talking about sounds like competence, and obviously in BCS there's the Sophia framework. There's a lot of definition of competence, but it's often very hard to put that into practical terms that you can actually assess. It sounds like you're starting to bridge that.
This is okay. I wish I had like another hour, or we had a pub to go to or something like that, because this is where my interest in philosophy education comes out, because and this is why I was focusing on the culture as well. I think it's an impossible task, really. You can't sit down and write down definitively, these are all the skills in a, all the competencies, or whatever it is you want, how you want to describe it, that will make you a good Python programmer, okay? Because there are so many different ways to be a Python programmer, okay? So the way the assessment works for code grades, and this is something I've been working on a lot, is that these are high-level criteria. So they involve things like, for instance, so, for instance, in the pairing task, this is a good example. The student doesn't just sit there; they're happy to ask questions, okay? Because a large part of my job as a software developer is actually, believe it or not, contrary to the stereotypes, we're a sociable group as developers, and we talk to each other a lot, and we're asking questions, we're writing documentation for each other, so they're not afraid to use that facility to ask their co-pilot questions and engage with the code in a collaborative sort of a way. Now, how that happens depends on who the examiner is, who the candidate is, what the code is, but you can get a general sense that this person is ignoring it because they feel that that might be they're failing because they have to ask a question, or it might be, they're asking too many questions, and this is why it's important that we have a professional coder who does this day in, day out, to get a sense of, well, where are they in this? We're trusting this person to act as the examiner and give us an accurate assessment of where is this person, and then give some actionable feedback. You're asking too many questions. Surely you understand what the call signature is for the print function in Python. It's just a string. You didn't need to ask me that. So just go ahead, do the thing that you need to do. It's that sort of a thing. It's an impossible job, really.
Yeah. There's a couple of questions that have come in. I'm currently new to the lecturing profession, and I can see how this would benefit university students, as we have had issues with programming assignments. My question would be, what level would you say that this could be adapted for?
So, like music grades, you could be an 8-year-old learning to program, or you could be an 88-year-old learning to program. And when working with the people who are creating resources, one of the requirements is we don't want lots of cute emojis and things that might appeal to just teenagers. This needs to be resources that you could show to lots of different people, and so that educators, lecturers, or teachers in schools, or people running code clubs or study groups, or the code, coffee and cake type movement that people are doing or were doing before COVID-19 hit us, so they have resources, teaching resources that they can adapt to their students, or they can adapt for themselves so that they're picking up those sorts of skills. A grade 1, I mean, obviously, a university student is a lot more developed than an 8-year-old in terms of things like literacy skill, keyboard skill, language skill, reasoning skills, that sort of stuff. You know, the sort of the whole Piaget sort of model of, you know, acquiring these sorts of things. So like music grades, you don't have to do all of them. You know, for my tuba, because I'd already played the piano a little bit, I did grade 3, then 5, then 8. So I didn't do the ones in the middle. I didn't need to. The velocity, I was catching up with my piano playing, and I was shooting through those grades. And I imagine university students could use the grade system as a scaffolding to help them understand, well, what do professional coders believe you need to know, and what skills you need to exhibit to become competent in the programming language that they are paid to write for a living. Okay, well, I've done grades 1 and 2 in the first fortnight or so, you know, get me onto the interesting stuff in grades 3, 4, and 5. It's also worth pointing out, you don't have to do all of them either. You might stop at grade 5 because you've reached the level that gives you the skills that you need to do the stuff you want.
Yeah. A couple of other questions. Have you attempted to map your grade system against, say, Key Stage 3/4 or degree level?
No, for the previous answer probably answers that.
Is criteria for each grade available now? If not, how long before criteria will be released? And is what's the one before that? Oh, is it available globally?
Okay, so let's work backwards. So is it available? It will be available globally because the assessment will have to take place online. I think, as we've all learned in the last few months, that you can get a remarkable amount of work done through this sort of medium, as what we're doing right now is showing. I have to admit, I much prefer giving talks face to face and being able to see the people I'm talking to. But you know, this is still a great medium through which to do talks. It will be done through a sort of a video conferencing type system, and the candidate will share their code with the examiner beforehand, so the examiner has a copy of the code. It's all done through the website as well, so the examiner understands where they need to be at a particular time. They click a button, they're in the meeting, they have the code, they have everything there, they have the assessment form in front of them as well that the candidate obviously can't see, and the assessment takes place. So it can be, you know, it's obviously designed to be without borders, but I'm British. A lot of my programming buddies are British or North American. We're English speaking as well. So we're focusing on the UK at the moment and running these experiments here in the UK to see how it works, because this is where most of the people involved in the project are based. Now, the question before that was, when will it be released? Well, in a typical software developer fashion, I'll say when it's ready. The syllabus is written, but we don't want to release the syllabus without having supporting content as well. So the syllabus is like the keystone, because that's the thing against which we're measuring our candidates, but it's also the thing from which you would build your resources as well, learning resources to support teachers and learners. So that's going on at the moment. The website is like I said, mostly complete. We're sort of trying to put the icing on top of that. So when that all comes together, hopefully over the summer, then we expect September to be able to show people what we would call a beta release. Again, the typical software developer here. So you know, you'll be able to see all the features, but there may be bugs. An important aspect of this is that we understand there will be bugs. And the reason we're iterating over various cohorts is to try and make this as smooth as possible. And each time you kind of increase the number of people who are encountering this, you encounter more and more edge cases. And we want to be able to cater for everybody, because everybody should have an opportunity to learn to code, just as they should be able to learn a musical instrument.
And some good application of agile software development.
Absolutely.
question here. Proportion. Trying to understand what you're saying. This might mean for the individual. A proportion of the time programming is a solitary activity, and a proportion of the time it's a collaborative activity. In the context of your presentation, can you suggest a figure for these proportions?
Okay. It's a that depends answer, like all the best answers, because the world is a complicated place. So let me tell you what I was doing today for the Ministry of Justice. Something went wrong and I needed to write a piece of code that fixed it very quickly. For that to happen, I'd been assigned this task. I needed to read a whole bunch of documentation, okay? And I was working on my own, and I submitted a script. Now, this is where it gets collaborative, to my colleagues in my team. And they then reviewed it, and we would drop into calls very much like this one, where I could see them, they could see me, we could see the code, and we did a code review where I would talk them through the code. We would discuss, was this the best approach, move things around, I might go back and change things, and so on and so forth. So on some days, it's a very solitary experience because you are gathering the context you need to be able to do something. On other days, you're working on code, writing the code, refactoring the code, where you're rewriting elements of the software that you're maintaining, and often best practice is that you do that in pairs, so there's knowledge sharing going on. So now there are two people who understand how that function works or how this capability works. So it's it depends. It's like a musician. Okay, I'm going to run with this metaphor until it's dead. Musicians can play as soloists, or they can play in an orchestra as well, and sometimes they play in chamber music as well, and it depends really.
And I'm a software developer currently changing career to computing teacher. I will be constrained by the national curriculum, but I hope that my professional experience will help me pass on this type of knowledge. Yeah. This sounds like you've done a lot of the work for me. Thank you.
Well, thank you for your kind words, and I just want to pay tribute to you for moving from software development into teaching. Teaching was the most difficult job I've ever done, but it was also the most rewarding job, and perhaps also the most important job you could do as well. So, you know, big thumbs up from me, and you know, keep a lookout online, and I'm sure, you know, Dawn, who's part of this group, will tell people when it gets released, and when it's in the beta. We love feedback, and we would encourage people to give feedback. So, you know, just jump in, let me know where it's broken, that sort of thing.
Great. And two last comments here. This presentation is so cool.
Thank you.
From Genevieve, and will you be my mentor? Somebody else on the call.
Well, okay, that last comment is interesting, because the whole point, we don't call them examiners in code grades, we call them code mentors. And when you go for your grading, it's supposed to be not like an exam, although it is an exam in a sense. It's more like a supportive consultation, after which you will get some feedback. So if you would like a mentor in coding, then taking some grades is a way to get that, and you will get professional software developers who are, how can we put it, vetted to make sure that they have the right people skills and pedagogical skill and smarts to understand how best to support a learner at that particular level, that particular grade, so that they get the most out of that experience.
Yeah. Okay. Well, thank you very much, Nicholas. That's been a fascinating session, and yeah, please keep us updated in the group about how this is progressing. And obviously, Dawn's on the committee, and it was Dawn's suggestion to invite you, and thank you for that, Dawn. I know you're listening in, and thank you to everyone who's asked a question. Really great session, so thank you for that, Nicholas. And
thank you.
We will be posting the recording on the website, so please share. Please tell other people about the group and about the work Nicholas is doing, and yeah, hopefully we can have you back in another session and get an update as to how this is progressing. But absolutely fantastic. So
hopefully
thank you very much. hopefully face to face next time. And thank you very much, everyone, for joining. And hopefully see you all next month's event. And next webinar, July 21st. And keep in touch with us either on Twitter or through the BCS member group's website. So thank you very much, everybody, and have a good evening. And see you all next month's event. And thank you, Nicholas.
Thank you. Bye-bye.
Thank you.